There are 3 simple things you need to know about us: where, why, and how. Where? Our project focuses on the Aboriginal communities in Port Hedland, Australia. Why? Our problems. Aboriginal communities have high instances of malnutrition, high instances of cardiovascular disease, low life expectancy, limited access to fresh food, and no access to reliable electricity sources. Our stakeholders. The Aboriginal communities in Port Hedland, the Australian government, and the citizens of Australia. Needs. The Aboriginal community needs a low-cost solution to the problem of malnutrition and cardiovascular disease, and a diet that includes more fresh fruit and vegetables. Their power need is about 63 kilowatts throughout the year, which means they will need about 200 solar panels and 10 wind turbines. How? Team design brief and criteria. Our design brief is to design a sustainable and low-maintenance greenhouse to allow the Aborigines to grow their own fruit and vegetables and to change their diet to include more fresh fruit and vegetables to reduce the number of Aboriginals with cardiovascular disease. Our project has to generate enough electricity and maintain a suitable environment to produce a sufficient amount of food, have minimal carbon footprint, and be self-sustained. It should be made from hard-wearing materials, be cheap to make and maintain, and easy to use, maintain, and construct. Final design solution. The crops we have chosen are tomatoes, spinach, and broccoli. The reason for this is that the climate in Port Hedland is suitable for planting these crops, and these crops are acceptable to the Aboriginals and therefore can be incorporated into their diets easily. Water for the crops will be sourced from the sea and desalinated. The desalinated water will be mixed with nutrient fertilizer and used in an aeroponic system. The solution overcomes the problem of poor soil quality available in the area. Energy. The solar thermal collectors will be used to heat water to evaporate it for desalination, and wind turbines for electricity generation. Solar thermal collection will use a parabolic trough design. The parabolic trough is constructed using mirrors with a tube running along the focus of the parabola. Oil is circulated through the tube and into a coil, which is placed in a tank containing salt water. The oil is heated and in turn heats the water, evaporating it. Condensation of the steam is done by passing it past pipes containing seawater before it has been moved into the heating tank, so some of the heat is recycled. The steam generated is condensed and put into a holding tank for the now fresh water, to be combined later with nutrients for watering the crops. A secondary insulated tank is linked to the tank with the coil to store water for heating purposes. When necessary, water from this tank is let into radiators in the greenhouse and passed back into the first tank. Heating the greenhouse will be done using the condensed hot water from the desalination system and cooling using evaporation techniques with sprinklers. Feasibility. Is this design technically feasible? Yes. It will generate enough electricity and desalinated water to sustain the energy and irrigation requirements. Economically viable? Yes. This project will produce enough food and electricity to pay for purchase of nutrients for the aeroponic system and eventually recover the initial cost of construction. Socially and environmentally desirable? Definitely. This design has a large potential to benefit the surrounding community by improving the supply of fresh foods and generating electricity without generating significant quantities of unusable waste materials.